Chapter 4, Carbon and its compounds. In the last chapter, we came to know many compounds of important to us. In this chapter, we will study about some more interesting compound and their properties. Okay, some of the interesting compound and their property we will study in this chapter. Okay, also we shall be learning about carbon, an element which is of immense significance to us in both its elementary form as well as its combined form. Okay, in this chapter we will study about carbon, detailed study regarding carbon. Now look at the items that come in the last column of a above table filled by you and your teacher. We will able to tell us that most of them are made up of compound of a carbon. Okay, in our daily life. Okay, we are studying. Okay, we are seeing a lot of things and objects which are made up of okay, carbon. Can you think of a method to taste this? What will be the product if a compound containing carbon is burned? If we burn what? Okay, compound containing carbon, then what will be seen? Do you know of any taste to confirm this? Food, clothes, medicine, books, or many of the things that you list. All basis on this versatile element carbon. Okay, we can see that food, clothes, medicine, books, and many other things, okay, which are totally made of okay, made of carbon. In addition, all living structure are carbon based. Okay, all of them are what? Okay, all of them are carbon based, and the amount of carbon present in the earth crust and in the atmosphere is quite measurable. Okay, what? Okay, there is a lot of things, okay, which are totally prepared by whom? Okay, it is totally prepared by the carbon atoms, and the earth crust has only 0.02 percentage carbon in the form of minerals like carbonate, hydrogen carbonate, coal, and petroleum. Okay, as you can see that 0.02 percentage of a carbon in the form of whom? Okay, carbonate, hydrogen carbonate, coal, and petroleum. And the atmosphere has how much? Okay, 0.03 percentage of carbon dioxide. How much? Okay, 0.03 percentage of carbon dioxide. In spite of this small amount of carbon available in nature, the importance of a carbon seems to be immense. Okay, in this chapter we will know about the properties of a carbon which make carbon so important to us. Okay, which are very important to us. Carbon, which are what? Okay, important part of any object. Okay, mostly we can see that all the objects are made by whom? Okay, it is totally made by carbon. Okay, so here you can see that all the things are made by a carbon, and we will study detail of carbon. Now bonding in a carbon, the covalent bond. In the previous chapter, we have studied the properties of ionic compound. We say that ionic compound have high melting and boiling point and conduct electricity in the solution or in the molten state. We also so how the nature of bonding in ionic compound explain these properties. Okay, some of the properties are explained by detail. And let us now study the properties of some of the carbon compound. Okay, some of the carbon compound here means what? Okay, compound which contain carbon. Okay, for example, here which is given acetic acid, chloroform, ethanol, methane, many. Okay, many of them are said to be a carbon containing compound. In short, a compound which contain a carbon are said to be a carbon containing compound. Okay, so most carbon compound are poor conductor of electricity, as we have seen in chapter 2. In chapter 2 we have studied that most of the what? Okay, carbon containing compound are poor conductor of electricity. Okay, from the data given in table 4.1. On the boiling and melting point of a carbon compound, we find that these compounds have low melting and boiling point. Their melting point and boiling point are little bit what? Okay, low and compared to ionic compound. And we can conclude that the force of attraction between the molecule are not very strong. Okay, force of attraction are not very strong. Their force of attraction are totally low. And since these compounds are large non-conductor of electricity, we can conclude that the bonding in this compound does not give rise to any ion. Okay, on bonding through which we can see that no ion will be raised. Now, in class 9th, we learned about the combining capacity, which we say it as what? Combining capacity means what? Okay, we are talking about valency of various element and how it depend on the number of valence electron. Okay. Let us now look at the electronic configuration of carbon. Okay, now we will see electronic configuration of different structure and the bonding of a carbon with other elements. The atomic number of carbon is 6. How much? Okay, atomic number of carbon is 6. What will be the distribution of electron in various cell of carbon? How many valence electron will carbon have? We know that the reactivity of elements is explained as their tendency. Reactivity means what? Okay, their tendency to attain a completely filled outer cell. Okay, outer cell, how much amount of tendency is there? Depend on that. That is attain noble gas configuration. Elements forming ionic compound achieve this by either gaining or losing electron from the outermost cell. Okay, this can be seen by whom? Okay, gaining or losing electron from the outermost cell. From the outermost cell, okay, how much amount of electron are gained and how much amount of electron are lost, depending on that outermost cell. Okay, its valency will be decided. And in the case of carbon, it has 4 electron in its outermost cell. Okay, if we talk about the carbon, it has how much? Okay, 4 electron in its outermost cell and need to gain or lose 4 electron to attain noble gas configuration. Noble gas means what? Okay, complete octet, which we said as a noble gas configuration. Okay, in which you can see that octet will be completed. Okay, if it were to gain or lose electron, okay, carbon, which have a tendency, it could gain 4 electron. How much? So carbon can able to gain 4 electron, okay, or which we said as C4 minus anion, but it will be difficult for the nucleus with the 6 proton to hold on to 10 electron. That is 4 extra electron. Okay, so it could lose 4 electron forming C4 plus cation, but it will require a large amount of energy to remove 4 electron. Okay, here you can see that what? So in the first case, it is saying that it could gain 4 electron. We know it very well that in a carbon outermost cell, how much electron are there? Okay, 4 electron are there. So it can easily what? Okay, it can able to gain 4 electron. Okay, and it can be what? Okay, anion. If a carbon is what? Okay, gaining 4 electron, then it is said to be anionic. Okay, which we say it is C4 minus. But if it will be difficult for the nucleus with the 6 proton to hold on the 10 electron. Okay, but we know it very well that in a nucleus, okay, how much? Okay, 6 proton are already present. Okay, it cannot able to hold how much? Okay, 10 electron. That is 4 extra electron. Okay, if we add 4 electron in it, okay, 6 electron is already present in the carbon, and further on we are gaining. Gaining means what? Okay, carbon is accepting accepting how much? Okay, 4 electron it is accepting. 6 was already present and 4 which it is gaining. So total how many electron will be there? Okay, 10 electron will be there, and it is what? Okay, nucleus will not hold 10 electron. Okay, so that is 4 extra electron. Okay, so this can be little bit harder. Okay, so it could lose 4 electron. Okay, rather than accepting 4 electron, carbon can easily what? Okay, lose 4 electron, but it would require a large amount of energy. But for losing 4 electron from the carbon, why 4 electron? Because we are knowing that how much in a outermost shell there are presence of 4 electron. Okay, if that 4 electron is losing, for losing that 4 electron we need a large amount of energy. Okay, for removing 4 electron behind a carbon cation with the 6 proton in its nucleus holding on to just 2 electron. Okay, and if we remove 4 electron now in carbon, how much amount of electron will be remain? Okay, only 2 electron will be remain. Okay, so this 2 was the case. Carbon can easily accept 4 electron and it can able to lose 4 electron. Carbon overcome this problem by sharing its valence electron other atom of carbon or with other atom of other elements. Not just carbon but many other elements form molecule by sharing electron in this manner. Okay, what? Okay, they will share its valence electron with other atoms. Okay, and they get easily what? Okay, they will form a bond. Okay, they will form a bond by sharing its valence electron with other elements or atom. Okay, the sharing electron belong to the outermost shell of both the atom, lead to both atoms attending the noble gas configuration. And before going on to the compound of a carbon, let us look some simple molecule form by sharing valence electron. Okay. The simplest molecule form in this manner is that of hydrogen. As you have done earlier, the atomic number of hydrogen is 1. How much? Okay, hydrogen atomic number is 1. Okay, hence hydrogen has 1 electron in its K cell. Okay, in a K cell which we have already studied in 9th standard, hydrogen contain how much electron? Okay, it will contain 1 electron, and that 1 electron will be where? Okay, that 1 electron will be at a K cell. Okay, so and it required 1 more electron to fill the K cell. Okay, so if hydrogen okay need what? Okay, 1 electron, then that hydrogen will share its electron with other atom and it will form what? Okay, covalent bond. Just now we will see. So 2 hydrogen atoms share their electron to form a molecule of hydrogen H2, which we say it is what? H2. Okay, 2 hydrogen atom has shared both its electron with each other. Okay, each other, and it will form what? Okay, H2 molecule. Which molecule? Molecule of hydrogen, which we said is a H2. This allows each hydrogen atom to attain what? Okay, here you can see that. Okay, in hydrogen, okay, you can see that electron is present. Both this electron will form a bond with each other, shared electron. An electron configuration of nearest noble gas, helium. Okay, by sharing a electron with each other, they will perform a electron configuration near about noble gas, which is helium, which has 2 electrons in its case. And we can depict this using dots or cross to represent valence electron. Okay, same way here you can see that the shared electron pair of an electron is said to be what? The constituent of a single covalent bond. The bond by which they are attached are said to be what? The covalent bond, which we say it is what? Okay, covalent bond. Okay, between two hydrogen atoms, and a single covalent bond is also represented by the line between the two atoms, which you can see. Okay, line. Okay, this is known as what? The covalent bond. They are formed by a covalent bond. The atomic number of a chlorine is 17. Okay, as you can see that atomic number of chlorine is what? Okay, 17. What will be its electronic configuration and its valency? Chlorine form a diatomic molecule. Chlorine form what? Okay, diatomic molecule, which is said as a Cl2. Can you draw the electron dot structure for them? Note that only the valence electron need to be depicted. In the case of oxygen, we see the formation of a double bond between two electrons or a two oxygen atom. Between two oxygen atom, there are what? Okay, two bond are seen. Two bond means what? Okay, double bond. Okay, double bond are seen between two oxygen. Okay, and this is because of an atom of a oxygen has 6 electron. How many electron are there? Okay, 6 electron in its L cell. In its L cell, you can see that there is a presence of how many? 6 electron, and it required a 2 more electron to complete its octet. Okay, for completing its octet, how many? 2 electron are needed. So each atom of oxygen share 2 electron with another atom of oxygen to give us the structure. Okay, to giving us a structure. The 2 electron contributed by each oxygen atom give a rise to share a pair of electron, and this is said to be constitute a double bond between two atoms, as you can see. Okay, as you can see, there will be a double bond between them. Okay, because they are sharing its 2 electron with each other. Okay, and they are forming double bond, as you can see, and this can be expressed as O double bond O. Okay, these two lines indicate double bond. Barabar? Double bond. Can you now depict a molecule of a water showing the nature of bonding between one oxygen atom and two hydrogen atom? Does the molecule have a single bond or double bond? What will happen in the case of a diatomic molecule of a nitrogen? Nitrogen has the atomic number 7. How many? Okay, nitrogen atom contain atomic number 7. And what will be the nitrogen atom has atomic number 7, and what will be its electronic configuration and its combining capacity? In the order to attain octet, each nitrogen atom in the molecule of a nitrogen contribute what? Okay, it will contribute 3 electron and give a rise to what? Okay, 3 shared pair of electron, and this is said to be constitute a triple bond. So nitrogen will form how much? Okay, 1, 2, 3 bond, triple bond, by sharing its 3 outermost or valence electron with each other. Okay, which we will see. Okay, here, as you can see. Okay, so hydrogen are sharing what? Okay, one of its electron, valence electron with another hydrogen, and it will form single bond. Same way we have studied about oxygen. Oxygen will share its 2 valence electron with another oxygen, and it will form double bond, which we have seen. And same way, just now, nitrogen will share its 3 valence electron with another nitrogen to form triple bond. Okay, as you can see, triple bond and triple bond and okay, so it will form triple bond. A molecule of ammonia has the formula NH3. Can you draw a electron dot structure for this molecule, showing how all 4 atoms achieve noble gas configuration? Will the molecule have a single, double or triple bond? Let us now take a look at a methane. which is compound of carbon. Okay, what? Okay, methane, CH, okay, 4, okay, which we said as a methane. Okay, methane is widely used as a fuel. Okay, methane is widely used for the fuel and the major component of a biogas. Compressed natural gas, it is also one of the simplest compound formed by the carbon. Methane has how many? Okay, CH4, okay, hydrogen, as you know, has a valency bond. Carbon is tetravalent because it has 4 valence electron. In order to achieve noble gas configuration, carbon share its electron with 4 atoms of hydrogen. Okay, 4 atoms of hydrogen to form. Okay, as you can see. Okay, carbon have how much? Okay, 4 electron outermost. Okay, valence electron. That 4 will share with a respected hydrogen. 4 hydrogen. Okay, respected 4 hydrogen, and it will form methane. Okay, such bonds which are formed by the sharing of electron pair between two atoms are known as covalent bond. Okay, here the bond which is forming between them are said to be what? Covalent bond. And covalently bond molecules are seen to have strong bond within the molecule, but intermolecular force are weak. Their intermolecular force are so weak. Okay, this gives rise to the low melting and boiling point of this compound. And since the electron are shared between atom and no charge particle are formed, okay, there will be no charge particle in between them, and there what? Okay, melting point as well as boiling point will also low as compared to another bonding. Okay, such covalent compound are generally poor conductor of electricity. Okay, they are poor conductor of whom? Okay, they are poor conductor of electricity. Okay.
Bonding in carbon, the covalent bond. Most of the carbon compounds are poor conductors of electricity. The melting and boiling point of acetic acid is 290 K, 391 K, and ethanol is 156 K, 351 K. From this data, the force of attraction between these molecules is not very strong. Since these compounds are largely non-conductor of electricity and does not give rise to any ions. Elements forming ionic compounds achieve by either gaining or losing electrons from the outermost shell to attain noble gas configuration. In the case of carbon, atomic number is 6. It has 4 electrons in its outermost shell and needs to gain or lose 4 electrons to attain noble gas configuration. Case 1. It could gain 4 electrons forming C4 minus anion, but it would be difficult for the nucleus with 6 protons to hold on to 10 electrons, that is 4 extra electrons. Case 2. It could lose 4 electrons forming C4 plus cation, but it would require a large amount of energy to remove 4 electrons, leaving behind a carbon cation with 6 protons in its nucleus holding on to just 2 electrons. To overcome this problem by sharing its valence electrons with other atoms of carbon or with atoms of other elements to form molecules by sharing electrons in this manner. The shared electrons belong to the outer shells of both the atoms and lead to both atoms attaining the noble gas configuration. Let us see some examples of formation of simple molecules by the sharing of valence electrons. Formation of hydrogen molecule. The atomic number of hydrogen is 1. Hence, hydrogen has 1 electron in its K shell and requires 1 more electron to fill the K shell. So, 2 hydrogen atoms share their electrons to form a molecule of hydrogen H2, and each hydrogen atom to attain the electronic configuration of the nearest noble gas, helium, which has 2 electrons in its K shell. The shared pair of electrons is said to constitute a single bond between the 2 hydrogen atoms. In case of oxygen, an atom of oxygen has 6 electrons in its L shell and it requires 2 more electrons to complete its octet. So, each atom of oxygen shares 2 electrons with another atom of oxygen to constitute a double bond between the 2 atoms. So, oxygen molecule is formed by the 2 shared pair of electrons. Formation of methane molecule. We know valency of hydrogen is 1. Carbon is tetravalent because it has 4 valence electrons. In order to achieve noble gas configuration, carbon shares these electrons with 4 atoms of hydrogen. The bonds are formed by the sharing of an electron pair between 2 atoms are called covalent bond. These bonds are very strong within the molecule, but intermolecular force are small.